All right.
Jake doesn't have it yet.
Oh, it is 7.1. Thank you. Okay. We've got ABC. A is a 60-degree angle. B is going to be a 75-degree angle. Little c is going to be square root of 2. All I want you to be able to do is find little a as an exact value. See how they gave me this side length as square root of 2? That's an exact value. They didn't give me decimals. I want little a as an exact value. So, we are still going to use law of sines from yesterday. To do law of sines, we need a side with an angle, so I can set up that proportion, because my goal is to get little a. And I've got its angle. Do I have a side with an angle here? Not yet. Can I find the side with the angle proportion? We just got to find this angle first. So go ahead, do the math. Tell me what angle C is. 45? Here's the head of the game. There are 45 degrees up there. 45 degrees. So now we can set up our proportions. How does that proportion work from yesterday? I told you it would be easy to remember. What is it? Square root of 2 over sine of 45. Don't forget the word sine, that's huge. Equals a over sine 60. Okay, this is where we break from what we did yesterday. Yesterday we picked up the calculator and did cross multiply and divide. If I want exact values, and I start doing square roots, the calculator doesn't do exact values. So we've got to not use the calculator here. Which means, how are we going to get the sine of 45 degrees as an exact value? On the golden sheet, that circle sheet. So revise that. Give me these two ratios from your circle sheet.
Should we be using this for like a whole?
Yeah.
I don't know if you need to do what Sam does and write your notes. Use the gold sheet.
It's actually kind of smart. But he knows.
Shut up.
Okay, so what is the sine of 45 degrees as an exact value instead of the decimal that the calculator would have given us? Square root of 2 over 2. And then the sine of 60? Square root of 3 over 2? Okay. Hey, it's the exact same process as we did yesterday. It's still going to be cross product. But keep an eye on your fractions here. So the a is going to get multiplied by that fraction. So I'm going to make it a over 1 times square root of 2 over 2, so that everything lines up. Are you okay with that? Oh, I'm off the screen. So all I did was make the a over 1, and then kept the square root of 2 over 2. I like, when I have fractions, I don't like to have something that's not a fraction. Then I can tell what's in the top, what's in the bottom. That cross product has to equal this cross product. So I'm going to make the square root of 2, square root of 2 over 1, times square root of 3 over 2. And I'm not going to multiply anything together yet. So far, so good? All I did was cross products, but I didn't even multiply anything. I just wrote them down. I want to solve for a. How do I get rid of this fraction? Multiply by its reciprocal. If I multiply this side by the reciprocal of this, which is 2 over square root of 2, that'll cancel out. So I'm going to multiply over here. 2 over square root of 2. See this? I want to cancel this fraction out. And it's being multiplied by a, so I would have to divide by that fraction, but what's the same thing as dividing by a fraction?
Multiply by reciprocal.
multiplying by, so what I'm doing is multiplying by the reciprocal of this, because watch what happens, see how the 2's cancel? So all I have left on the left-hand side now is the A. And because I didn't multiply anything together here, stuff cancels out. What cancels on the right-hand side? Square root of 2's go away, and the 2's go away. What's my final answer? That's an exact answer. So it's a little more challenging because you couldn't pick up a calculator, but not impossible. I know. Because we can. I don't know the reason for doing that other than because we can. Okay. That was one thing I want to do today that was different from yesterday. The next thing is the area of a triangle. What do you know the formula to be for the area of a triangle?
1/2 base times height.
I'm going to give you another formula right now. You didn't know that? Area of a triangle, if you know, if side angle side is known. And there's a great big development to this formula. This is one I don't think is valuable to take our time to actually go through. So I'm just going to give you the formula. So, if you've got two sides and the included angle, so let's go, let's say we've got little a, little b, and we've got angle C. Okay, doesn't quite fit on there, does it? I'm going to zoom that out a little bit. Oh, this thing's itself. Wrong way. There we go. That's better. So if you know those three parts, it's a simple plug-and-chug formula. The area of the triangle is equal to 1/2 times side A times side B times the sine of the angle. I don't know why I put side in there. 1/2 A B sine C. But the parts have to be in side angle side order. And it's just a simple plug and chug. Again, I'm supposed to take you through the big development of this, but I don't think it's worth your time. Was that what you were thinking too?
Yeah.
We were on the same thinking page? All right, that's good. So all I want to know is, can you use this? You gonna make it back there?
No, this is why I didn't go to school.
Oh, this is why you didn't go to school yesterday.
Yeah.
I appreciate you not going to school yesterday.
Oh, thanks. I feel great about that.
Keep your sickness at home.
Can I go get a coffee?
See, there's a 5-foot radius here on my desk you're not allowed to come into either. You're gonna pass through my 5-foot radius. Go back around there. Turn around. All the way around there. Thank you.
She's interrupting others, you know.
Yep.
I'll go back home.
You can.
Whatever.
You
have a great day.
Okay, can you find the area of triangle ABC? Do you have side angle side parts that you can use in the plug and plug formula?
Yeah.
So what did I give you that you're not going to use? I gave you an extra piece of information. I wanted you to know that you could throw that away because you want the parts that are in side angle side, not this extra one. Yes, I did. The book doesn't do that, but I thought I would. So the area is equal to one. It's just simple. Plug and chug. 1/2 times the two sides. It doesn't matter what order they come in. 28.4 times 30.4 times the sine of the angle. The sine of the angle is 124.5. Simple plug and chug. If you do that, I'm going to find our last bearing problem. practice some bearing. Yeah, it's kind of dying out there, I don't know.
Kind of depending.
355. Yeah, Mrs. Ward is
What?
only concerned. Don't get me sick.
Yeah, back, stay out of my zone. I don't like that sickness business. Okay, can I get rid of this? What was it?
355.8.
Square unit. Okay, last one's a bearing problem. See how you do.
You guys are big.
Well, I actually found the answer.
Really?
355. 355. Units were.
Okay, we've got two stations that are 113 miles apart on an east-west line. A large forest fire is located on a bearing of north 42 degrees east from the western station. So from the western station, fire is north 42 degrees east. From the eastern station, it is north 15 degrees east. Find the distance of the fire from the west. Find west to fire. Distance. That means she's still alive, so it's all good.
Where or what?
Yeah, 50. I got it.
Okay.
Okay.
What do you mean find W to 5 distance?
Fire.
Oh.
From the western station to the fire. You couldn't decipher that hieroglyphic word there?
Sorry.
Fire. All right.
I have contacts, I don't know.
All right, here we go. Picture. So you can get the picture. These are not difficult. Start with an east-west line. We've got two stations that are on there. I will call them my western station and my eastern station. How original. And how far apart are they? 113. Okay. From the western station, the bearing is from the north 42 degrees to the east. So east. So when you see bearing, what should you put in right away? A north reference line. So that means if I look straight ahead north, how much do I have to turn before I can see the fire? 42 degrees to the east. So somewhere over there is the fire. So I'm going to rotate over 42 degrees to see this fire. Okay? From the eastern station, it gives me a bearing, so I want a north line. Keep the same color here. You can make this work if you have to.